This is take 2 of a beautiful presentation. My battery was dead for my original. I'm going to show you today a trick for solving equations that involve fractions and decimals. Let's begin with this problem. 3/4 x plus 7 equals 5/6. Now, a fraction is simply a rational number. Any number that can be expressed as a ratio of two integers is rational. So we have fractions, we have mixed numbers that can be written as fractions, we have whole numbers that can be written as fractions, etc. In this particular equation, we could solve by subtracting 7 and dividing by 3/4, but you have to remember your rules for working with fractions. Here's another way. I can multiply both sides of an equation by the same number and the equation remains the same. In this particular case, I want to multiply both sides by a number that will get rid of the 4 and the 6. And that'll happen if 4 and 6 both go into this number. So what's the smallest number that 4 and 6 both go into? Why, it's 12, the least common multiple. So I'm going to multiply both sides by 12. Now when I multiply both sides by 12, that means I multiply every term by 12. So that's 12/1 times 3/4 times x plus 12 times 7 equals 5/6 times 12/1. I'm just putting 12/1 so I can multiply. Now I'm going to look for common factors. In this multiplication problem, I have 12/1 times 3/4 times x. I have a common factor of 4. 12 divided by 4 is 3. 4 divided by 4 is 1. There goes that denominator. I'm done with it. And then on this side, to multiply this fraction, I have 5/6 times 12/1. 6 goes into 12 one time. 12 divided by 6 is 2. That denominator goes away as well. So when I'm done, I have a nice pretty equation. 3 times 3 times x is 9x plus 12 times 7 is 84 equals 5 times 2, which is 10. Now to solve this equation, remember first you undo addition or subtraction. To undo the plus 84, I subtract 84 from both sides. 84 plus 84 minus 84, those are opposites, so that goes away, and I'm left with 9x equals 10 minus 84. Remember, you put the bigger number on top to subtract, so I know it's 74, but my answer is negative 74. I'm taking away more than I have. So now I divide by 9 to undo the multiplying by 9, and I get my answer. X equals, let's see, 9 goes into 74 8 times, so it's going to be negative 8, and there's 2 left over, so my answer is negative 8 and 2/9. Now if you remember, I said something about decimals as well. How does this work with decimals? Let me show you. Here's this equation. 25/100 times x minus 4 is equal to 5/10. Wow. I can solve this by adding 4 to each side and dividing by 25/100, but then I have to worry about my decimal points. Here's a way to get rid of those. What can you multiply both sides by, in this case, to get rid of the decimal point? Well, I know if I multiply by 10, it moves the decimal point over one spot. I need to move it 2, so I'm going to multiply by 100. Remember, I'm multiplying the whole thing by 100. That means I'm multiplying every single term by 100. When I do so, I get 100 times 0.25x minus 100 times 4 because I'm distributing. That's how you distribute. And that equals 0.5 times 100. All right? So 100 times 0.25 is 25x. It moves that decimal point over 2 spots. Minus 100 times 4 is 400 equals 0.5 times 100. When I move my decimal point 2 spots for the 500, or the 0.5, I get 50. Now I'm going to add 400. I have to undo my subtraction. All right, that leaves me with, these are opposites, they go away, that leaves me with 25x equals, I didn't line that up very well, 50 plus 400 is 450. I divide by 25. Oops. How many quarters are into $4.50? I think there's 18. 250 plus, yeah, I think that's right. You correct me if I'm wrong. Okay, I'll see you in a bit.